In this video, we will practice the basic network concepts. We are going to represent this following network, which is the network representing the relationships between the Florentine families in early 15th century Italy. Now, this network has been studied for good, and if you've heard about the Medici family, for instance, it has been proven through looking at this network and other kind of networks that the Medici family had some unique position in these networks that allow them to leverage considerable power and influence during this era. In this network, the nodes represent families, and the edge means there is a marriage relationship between the two families. We have two questions here. First, we want to use network X to represent the network and then draw it. This is a picture. This is a picture in Markdown. We're just basically loading the network image from the internet. We're going to use network X to represent the network and then draw it within Python. Once we do that, we have a question here, which is to report the largest clique in the network. So I'm going first to import network X. And next I'm going to create a network object by calling the function graph. So let's call this network net. I'm going to do graph. Obviously this is not a directed network, it's an indirected network, because if there is a marriage relationship between the two families are in-laws, it's kind of symmetrical. Here we don't differentiate. The next step is to add a node for each family here. So we're going to do add node and go over each one of these families here. Now this is manually constructing the network, and as we will see toward the end of this exercise, I'm going to show you how to save the network in a file and then load it in network X, so you don't need to recreate the network manually each time. For now, I'm going to add a node representing each family. So we can start with the family Accioli, I don't know how to pronounce it. And obviously there are so many nodes, so I prepared the list of families here, and I'm just going to paste it so I don't just waste the time typing each of these. Okay, so we're adding a node representing each one of the families. Then the next step is to add an edge representing each edge or relationship in the family. So for instance here, if you take a look at Accioli and Medici, there is such a relationship, so I can do add edge Accioli and Medici, and that will be one edge. Once again, I prepare the list of edges so I don't waste time typing all of them, but basically we need to add all of the edges to the network. Once we do that, we can draw the network, so I'm going to call the function draw here, and I'm going to pass my network, and obviously I want the drawing to be with labels, so I'm going to put with labels to be true, and that's basically the network here. Now as you can see, it doesn't look like the network up, and indeed each time you draw the network you're going to get slightly different one. The reason this is the case is that there is no deterministic way of drawing the network. Indeed, there is a slew of algorithm called network layout algorithm, which can be used to determine or to set the layout of the network when drawn. When we do draw, the algorithm itself is taking some default choices, and there is an element of randomization. The network is the same, but just the position of the nodes on the graph are kind of different. So what I have done here, I just tried with a couple of them, and this one seems to be okay enough as a network plot. The next question now is asking us to report the largest clique in this network. So what we can do now, we can use the function clique containing node. Next, we're going to use the function cliques containing node to report all of the cliques in the network. And that basically gives me all of the cliques as a dictionary. Each one of these nodes is associated with the list of cliques. Some of these networks are members of one clique. For instance, this family is only a member of one clique because it's only related to the Medici. But for instance, if you take a look at the Medici, it's a member of multiple cliques. There is this clique here, Medici, Ridolfi, and Torombiuni. There is this clique, Medici, and this family, Medici and Salviati, and so on and so forth. So if you take a look here, you can see that the Medici are part of multiple cliques. And that's the same for other families that seems to be more related to other families. Now what we want to do here, we want to report the largest clique in this network. And just looking at the network, it seems to me that there is a clique of 4 here. If you take a look at this clique, Castigliani, Peruzzi, Strozzi, and Bicciari, this is a clique that has 4 nodes. Maybe there are more, anyhow. So we want to go methodologically about this, the outcome of the algorithm, which is a dictionary of family and cliques, and just filter out the clique that has the largest size. So to do the math, we can either use Python or we can use pandas. If we use Python, then we need to kind of pay attention to the structure of this dictionary. It's a dictionary associating each one of these families to a list of cliques, and we're interested in the length of each one of the cliques. So what I'm going to do first, I'm going to look at the list of values rather than the keys, because I'm not interested in the keys here anymore. Now each one of this list is also a list, so I want to go for each one of these lists. Let's call them LL for now, because it's a list of lists or list of cliques, LC, for LC in this one. Now if I do this, I'm still getting a list of lists, and that's what I need to do. I need to go beyond that. I want to go for each one of these. I want to go for each clique in this LC. So I'm going to do for clique in LC. Finally, I need to flip the order here. So I'm going to go, because it doesn't recognize LC here, I'm going to define LC first, for LC in the cliques, and then for C in LC. What I get here, I get a list of the cliques. It's kind of like flattening this 2 nested list. Okay, so that's step number 1. Step number 2, I'm interested in the length. So there are a couple of ways to doing this. We can do the list of cliques here. Let's call these cliques. Then I can use sorted cliques, and this will sort based on natural ordering. That's not what exactly I want. I want the sort to be based on the length. Obviously this is length ascending, so we need to really go to the end to see the largest clique here. So what I'm going to do here, I can do either ascending is equal to false, or I can make a function which is minus length. Let's see the parameter here. Reverse, it's actually reverse rather than ascending. So reverse is equal to true. And that's basically giving me the length, the largest clique, and they seem to be cliques of 3 in the beginning. I want just to go to the figure, because I thought here there is a clique of 4, but I was mistaken here, because as you can see, Castigliani is not related to Bicciari here, right? And this is not a clique. So again, I mean, we take a look at the figure, we get an intuitive understanding of what the network is about, but it's not a silver bullet. We need to run the numbers first. So that's one way to do it, and we can see here that there are a couple of cliques of size 3. Finally, let's talk about importing and exporting this network. So to export the network, NX provide a different set of functions that start with the prefix write. This is basically writing the network to different files of different data types. One of the popular one is called GraphML, and GraphML is basically an XML format used to store the network. It's one of the most interoperable data formats for networks. Obviously, there are other choices, and it ultimately depends on the set of tools that you're using to process the networks. I'm going to use GraphML here, and I'm going to write this network to the data folder, and let's call it Florentine GraphML. This means that in the future, if we want to read the network, for instance, let's call net2, we can use the function read GraphML and do the opposite, reading this from network data / Florentine, and we basically get the same network. So this is useful whenever we have large networks, and many often these networks come from different data providers, different data sources. They will come in files, different formats that we can read, and we can also write our own files, network representing networks.